So today's lesson is talking about probability. You guys are going to be able to find the probability of different types of events that occur. Okay, and so we're basically starting with the basic probability theory. And basically what probability does is it analyzes random experiments. And basically what a random experiment is something that we cannot predict the precise outcome of. Okay, so for example, we can't flip a coin and know automatically that's going to land on hit. Okay, but what we can do is that we can figure out the list of all the possible outcomes that there are for a particular experiment and decide how likely the experiment may be. So for example, if we roll a fair die, okay, a fair one, not one from like a casino or something like that, but a truly fair die. If we roll a die, then we have a set of possible outcomes, which are, landing on a 1, the 2, 3, 4, 5, and 6. Okay, those are the different heads that are on a fair die. Now, we're going to let event A be rolling an even number. Well, those only options that are 2, 4, and 6, of course. And then B, be rolling a prime number. Our prime numbers are going to be 2, 3, and 5. We do not consider 1 because 1 is not a prime number. A prime number is a number that's greater than 1 that's only divisible by itself and 1. So the probability of A, so this notation right here is how you'll know that you're going to be dealing with finding the probability. Okay, so the probability of a particular set, in this case A, is equal to the number of outcomes in A divided by the number of outcomes in the universal set. Well, the number of outcomes in set A was 3, and then the number of outcomes in our universal set was 6. So the probability of rolling an even number is basically 1/2. The next one, the probability of B. So what's the probability of rolling an even number? Well, that's the number of elements that are in set B, which are 3, divided by the number of elements which are in the universal set, which is 6, which is again another 1/2. Okay, so you can look at the list them out and see how many elements you have in each particular set, or if you want, you can use a Venn diagram. Okay, a Venn diagram, which we've been working on. In this case, they do have some things in common, some numbers that are shared between an even number and a prime number is 2. That's the only number. The rolling an even number is 4 and 6, and then rolling a prime number is going to be 3 and 5, and so of course 1 will be in the universal set. Okay, you can also look at it and see, all right, how many are in A, circle A, that's 3 elements out of the 6 total, and then there are 3 elements in circle B out of the 6 total. Now, if all the equally likely possible outcomes of a random experiment can be listed in U, of course our universal set, and an event A is defined by and represented by set A, then the probability of A equals the number of elements in A divided by the number of elements in U. That's like your formal definition of probability there, okay? Now with this definition, there are 3 consequences of this law, okay? The probability of you getting something from the universal set is always equal to 1, okay? No matter what, whatever's in the universal set, all the probabilities will equal 1. The probability of getting an empty set is 0, because if you think about it, you divide the number of elements in the empty set by the number of elements in the universal set. Well, the number of elements in the empty set is always 0. 0 over any number is going to equal 0. And lastly, probability is always between 0 and 1. Okay? So whenever you're doing probabilities, you should get a number that's between 0 and 1. If you don't, then you probably did something wrong. Okay? So from our previous example, the example of rolling a fair die, the probability of us rolling an odd number, for example. Okay, actually, yes, let me fix that. I miscounted. All right, so it's the probability of A complement. Remember, A complement is everything that's not an A. So everything that's not an even number would be an odd number. So this would be the probability of rolling an odd number. Well, there are 3 odd numbers, just like there are 3 even numbers, so it'll be 3 out of 6, which is equal to 1/2. Right here, the probability of the intersection of A and B. So that's the probability of rolling an even prime number. Well, an even prime number, the only option of that was 2, so that's going to be 1 out of 6. What's the probability probability of having A complement intersection with B. So that's basically like saying rolling an odd prime number. So rolling an odd prime number would be a 2 out of 6 because 3 and 5 are odd numbers. They're both prime. So that would be a 1/3. And then the last one was the probability of A union B. Well, that is the probability of rolling an even number or a prime number. Well, there are 3 even numbers. There are 3 prime numbers, but there's one that they have in common. So you don't want to count that twice. So there's a total of 5 numbers that are even or prime out of the 6. So that'd be a total of 5, 6. There are 2 further laws of probability that you also have to make sure that you're aware of. For complementary events, the probability of a complementary event is equal to 1 minus the probability of that event happening. Like if we take the last example, right? A was the set of rolling a even number, right? Well, if we wanted to figure out its complement, which is rolling an odd number, we would do 1 minus the probability of rolling an even number, okay? Well, 1 minus a half is a half. And so that would be the probability of rolling its complement, which is basically rolling an odd number. Now, I know that's a pretty easy example to use, but depending on the type of problem that you're dealing with, that particular law can actually be very handy, okay, having that. You could also look at it as like, okay, let's just say event A was rolling, so say you have a die, but rolling a 6, okay? Well, then the probability of a complement would be rolling something other than a 6. Well, then instead of trying to figure out, okay, well, what all numbers do we have? We could just do 1 minus 1/6. That's the probability of rolling a 6. We want the complement, which is probability of not rolling a 6, which is 5 out of 6. If you think about it, there are 5 numbers that aren't 6, so it would be 5 out of 6. So the last one, combined events, is the formula. It's basically a formula here, a law that can help when you're looking at Venn diagrams, looking at unions and things. The probability of A union B is the probability of A plus the probability of B minus the intersection. So basically, when you look at a Venn diagram, you have A and B. When you're trying to find the probability of the union, what you do is you take the probability of A, you take the probability of B, and then you subtract the intersection. Because if you look here, if we take the probability of A and the probability of B and add them together, we're basically counting the middle twice. So we need to subtract the intersection to take away one of the times that we counted. And then that would give us the full probability of the union. So we're going to apply some of these laws, the concept of probability, to a few examples. So here we have an experiment, a random experiment tossing 4 unbiased coins, okay? Now, if you want, and now one thing to help think about is like you're tossing 4 unbiased coins. Now, it's not like you're putting 4 coins in your hand and just throwing them up in the air. No, it's like you're taking 4 coins and you're flipping them individually, okay? So we're going to find the probability of there being no heads. Well, if you think about it, the probability of rolling no heads is going to be 1/2 on 1 coin. So it's going to be 1/2 times 1/2 times 1/2 times 1/2. So 1/2 raised to the 4th power is 1/16. Okay, and if you think about it, the likelihood of that happening will only be 1 time out of the possible 16 times that 16 options that you can get. Okay, probability of rolling 4 heads is kind of like the opposite of rolling no heads. Okay, because if you have no heads and then you have all heads, it's still the same probability of 1/16. Now, the probability of rolling 1 head is going to be 4/16 or 1/4. Okay? Because that means that each individual coin at one particular time could eventually roll a head. Okay? So you could have 3 tails, 1 head, 2 heads, or 3 tails, 1 head, 2 tails, 1 head, then a tail. 1 tail, 1 head, and then 2 tails, or 1 head and 3 tails. Okay, so that's 4 out of 16 options. And then with 3 heads, it is the same. Okay, so that's going to be 4 out of 16. So we're going to use the answers from A to D to deduce the probability of you rolling 2 heads. Well, to use the information from and D is basically talking about using the complement, okay? Because the probability of rolling 2 heads is basically 1 minus the probability of rolling all your other options, which are no heads, 4 heads, 1 head, or 3 heads. Okay? So if we add all those up together, that's going to be 10/16. And so when you get a common denominator of 16/16 minus 10/16, which is 6/16, or basically 3 out of 8. Okay? Now that's why I left them up here as 4 out of 16, because I knew later on that we were going to be doing using these answers, and it would have been a lot easier to work with if they're all in the same denominator. Okay? Now, if you've been confused this whole time about how is this even possible, well, let's list out the likely possible outcomes. Okay. Well, one outcome is you can have, all 4 heads, just like you can have 4 tails. Okay. Well, you could have 3 heads and 1 tail, and this is not the only option that you can have. Okay. You can have 2 heads, a tail, and a head. You can have a head, a tail, and then 2 heads. Or you could have a tail and 3 heads. Okay? Now your options for 2 heads. You could have 2 heads, 2 tails, a head, tail, a head, and a tail. You have a head, 2 tails, and a head. Okay? You could have a tail, 2 heads, and a tail. You can have a tail, 2 heads. Okay, these are all the different possible combinations that you could have. Right, and if you look, that is 6 options. Okay. As for 1 head, you could have head, tail, tail, tail. You could have tail, head, tail, tail. You could have tail, tail, head, tail. Okay, that's where 16 came from initially, okay? Because think about it, you're flipping these 4 coins one at a time, okay? So the first coin is flipped, then the second coin, then the third coin, then the fourth coin, okay? The effect of the first coin has no effect on what's going to happen with the second flip, okay? So you flip first, you get a head. When you flip the second coin, you're still going to have 2 options, a head or a tail. So that's why you have as many outcomes as you see listed here, okay? Let's look at this one. You have music lessons in piano, violin, and flute are offered to students in the school. The Venn diagram shows the number of kids who learn each kind of instrument. We're going to write down the total number of students in the school. Okay? Well, if you sit there and you add up all those numbers, you're going to see there's 145 students in the school. Okay? So now you're going to write down the number of schools who learn violin only. Well, the ones who do violin only are the 56. They're the ones that are only in the violin section, not shared by any other section. To learn the piano or the flute or both, well, you have the ones who do piano, you have the ones that do flute, or the ones that do both. And so you're going to add those up, which is 85. And then the ones who did not learn how to play the flute, that's everything outside of the flute circle. And so then that would be 89 students when you add up 21, 8, 56, and 9. Okay, now for the last part, it says explain in words the meaning of the part of the diagram that represents P intersection of F complement, okay? Well, P represents the piano. F complement would be that did not learn the flute or did not play the flute, and so the intersection would be the number of students who play the piano and do not play the flute. And you have to be very careful with the wording when you're doing this, okay? You have to be very careful with the word. The reason why I say is because when I look at the mark scheme for this question, it says do not accept the word but. You would need to say the number of students who, or the students who play the piano or learn to play the piano and did not learn to play the flute. You don't want to put but, okay? So just got to be very careful on that wording. All right, we're going to look at this one.
And actually, this one is actually the one that you're supposed to do for your homework. So you need to complete this one for your homework, and then be ready because we're going to use this to go into the next concept that deals with probability. So if you have any questions, just make sure you bring them to class, the next class.